In this video I'm gonna explain this SVM how to apply after making changes here. Here we have taken multinomial NB algorithm, and we have taken the subset from fetch 20 news groups, and afterwards we have trained the model, and we have transformed it. So apart from that, we have used this SVC linear kernel, and we have checked both accuracy scores after predicting and checking the predicted and actual target value. So these two scores, and afterwards we have used this n-gram range, here bigram and stopwords. So yeah, here we have used stopwords, and previous one we have used this bigram. So after running this we get output. It's taking so much long time. Let's run it again. uh, Let me show the output. This is the output I got for multinomial apply SVM bigram and stopword. So it's taking time. We shall check the next one, scrapping. So we shall stop this. Here we have imported all the libraries, beautiful soap, and after reading this URL, so we get data in the form of HTML tags. So here I'm taking only soup body get text. Let me run this, run scrape. So it gets executed. Here I'm getting only text, so the text will be, so the text will contain so many new lines and everything. So here I will use this dot split lines, and each line I'm taking it, and I'm stripping it and keeping in list. We can see the list just I printed for understanding this print lines. So every new line it's getting just quotes, and from this I'm taking each element from the list, and I'm checking for double spaces using dot split. If it contains any double spaces, so it again strips. So again I'm printing these chunks. We can see the second output here. So it removes all the double spaces, and afterwards from this list I'm taking each zero element, one element, and everything. And if the data it contains, I'm joining it to the empty string. So here we can see I have printed this empty after joining the strings. So here we can see the empty strings, these all are removed. Why? Because if it gets true only, it joins, or it joins into the empty string, otherwise it won't. So afterwards it saves into we need to encode before saving, so it converts into byte data. So for writing we need to, it should be in string, that's why we have converted to str, and we have written in text file. So yeah, here we can see the input file. This got saved, so this is the data we have saved, and afterwards we are opening the same file using f.read and everything. So this sentence tokenize and word tokenize I have performed here. So sentence tokenize is like we can see yeah, this one, byte data list. So this is the output we get when we print the s tokens. So every sentence it keeps in 0 element, 1 element, and so on. If we keep this one in for loop, and if we get printed, it comes in new line. The same thing with words. So here I've used for loop so that each word comes in new line. We can see here new line, new line, new line. The same task I have done is done in here also. Here I have here I have done the sentence tokenized directly. You can see the data down. So this next one is parts of speech. So for that I am taking nltk dot pause underscore tag so that it tags for each word we can see nn. This is the default tagging. So like this it gets tagged for each word. And next one is stemming. Stemming is like it's a post stemmer for each word. It removes last characters. So I'm using here p stemmer dot stem of I and end. So here I'm giving snowball stemmer of English and it gets stored in this stemmer variable, and using that again I'm stemming dot stem of I means w tokens. It contains list one element and it stems the elements. Next one is lemmatization. This take the word and it converts it prints the root element. So for that lemmatizer of read data. So this read data is nothing but what we have read that input.txt. Here you can see the read data file.read. So after this stemming and lemmatizing, next one is trigrams. So we can see here each thing contains three words. We are listing into w tokens comma 3. So here we have given list, so it will be in the form of list. So we are giving trigrams. And name entity recognition is like, so each data it contains one name. Using this word punch underscore tokenize, we are tagging name entity, and we are printing the type. This we can see it will be in the form of nltk.tree.tree, and each one we are taking it and we are printing. We can see everything came in new lines after giving name entity. Thank you for watching.